Okay, it's Mrs. Blankenbeckler back with how do you switch from standard form to vertex form. This is the more difficult of the two. We learned this last year, but if you didn't learn it, this is your chance to catch up. Okay, this is called completing the square. Okay, so the method we're going to use to move from standard form back to vertex form is called completing the square. Now, why is it called completing the square? What we've got to do is we have to create a perfect square. So, we've got this in the ax squared plus bx plus c form. We're trying to get it to vertex form. So we have to get it into the x minus h squared plus k form. Notice we have a perfect square here. We've got to create that, okay? And I'm going to show you how to do that. It's really pretty easy. Okay, we have to first identify what b is. B in this case is 10, okay? And I'm going to sing a little song. You half it and you square it and you add it and subtract it. Now sing it with me. You half it and you square it and you add it and subtract it. When you do that to b, you can complete the square. So what I'm going to do is I'm going to group these two terms together, my ax squared plus bx together. And I'm going to complete the square by taking my 10, just the b part, just b, so b is 10. I'm going to half it and I'm going to square it. And I'm going to add that number and subtract that number. Okay? So what's half of b? 5. 5 squared is 25. So that's the number I'm going to add and subtract. So I'm going to add a 25, but in order to make it zero out, I have to subtract 25 because I'm keeping this equation the same by adding a number and subtracting a number. Okay? So now what I've created is a perfect square trinomial. How is that going to factor? Well, what multiplies to 25 but adds to 10? That's going to factor into x plus 5 times x plus 5. What's another way to write that? X plus 5 squared. X plus 5 squared. So what I've done is I've created a perfect square by completing the square. That's what's completing the square. Then out here, all I have to do is combine my constants. 3 minus 25 is a negative 22. And there is my function now in vertex form. So what is the vertex? Opposite of h and the same as k. Negative 5 and negative 22. And you have this formula in vertex form. Okay, so I did that in 3.5 minutes. Let's try one more just for practice. And you can stop the video here after I put the example up and see if you can do it, and then just fast forward and see if you get it right. Okay, so f of x is equal to x squared plus 6x plus 3. Okay, stop the video if you need to and see if you can work it out. Okay, I'm going to keep going now. Here we go. I'm going to group the first two together. I'm going to take b, half it and you square it and you add it and subtract it. Half of it, half of 6 is 3. 3 squared is 9. So I'm going to add and subtract 9. X squared plus 6x plus 9 becomes my trinomial. But I added and subtracted, so it ends up being 0. So I'm going to add, bring down my 3, and then since I added 9 here, I have to subtract 9 here to keep it 0, right? 9 minus 9 is 0. Now I'm going to factor what I just created, which is a perfect square trinomial. What multiplies to 9 that adds adds to 6? We know it's 3 and 3. X plus 3 times x plus 3, or written x plus 3 quantity squared. So there I've shown you that completing the square portion. Now let's just bring down our constant, or our k. 3 minus 9, negative 6. So there we go. We have that on the outside as a negative 6. So what are my a, h, and k now that I've got this from standard form to vertex form? The vertex is opposite h and the same as k. Negative 3 and positive 6. And you're done. So hopefully you got that second one. Okay, good luck. I'm here to help you, and see you next time.